Thanks for asking me to present, and it's been really good to see the previous presentations, really interesting. I've made lots of notes, so that's fantastic. Just a quick introduction. I work in the Innovation Discovery team for Anglian Water. I'm a project manager. My disciplines are water treatment distribution, although I do get involved in the catchment side as well, and looking at what comes through into our treatment works. And today I've been asked to give you an overview of the biofilms in the UK, but more specifically from an Anglian perspective. So what we're going to do, I'm just going to give you a quick overview of Anglian Water, just for some of you may have heard of us before, but those that don't, just where we are. I'm going to look at a historic perspective of biofilms, how we've been identifying them, then look at some categorizing, and how we look at understanding them, monitoring, and how we look to try and find out where we have issues, and then I've got some final thoughts. So this is a map here of the UK, and so the Anglian region is in blue here. We go right the way up to the Humber estuary here. We go down into Milton Keynes, Essex, and out into Norfolk and on the coast there. In the UK, geographically, we're the largest water company. We're also the driest, one of the driest. We only have 2/3 of the national average of rainfall. We supply about 4.3 million water customers. And if you include wastewater as well, that's just over 6 million. Across our region, we've got, it's a 50-50 split on boreholes and surface waters. So we've got just over 400 boreholes. We've got 8 large reservoirs, and we've got 9 river abstraction points that we abstract from. I guess the reason I'm just mentioning that to you is just important when we think about biofilms is about where that water's coming from and what's coming through the system. So is it a confined aquifer with low organics, or is it a reservoir or a river where we've got different times of the year, we've got quite high organic loading? And what impact is that having in our systems? We've got 143 treatment works, and roughly every day we supply over 1 billion litres of water to our customers. And again, this is another probably important statistic for you guys, is that we've got about 38,000 kilometres of mains across this area. So for us to try and get to understand biofilm and what's happening in those 38,000 kilometres, is something that's really, really important to us. And yeah, the impacts. So how does biofilms impact Anglian? Recent work with universities like Sheffield have been looking at modelling and looking at distribution system modelling, particularly with things like discolorations. And what we've learned more recently is that discolorations, it's not just iron and manganese, it's how they're held to the pipe wall. That generally, or we're learning that that's an interaction with biofilm, and then the stability of the biofilm can have a big impact on our discolorations and the water quality. Also, we look at tests like plate counts, and we run IDEX for indicator organisms like coliforms. So occasionally we can pick up high levels, and I guess it's about understanding what's in the bulk water, what's on the biofilm, whether the biofilm are harbouring what's in the bulk water, and it's about that interaction as well. So at what point do we detach parameters that are giving us issues in water quality monitoring, and how does that happen? So from a historical perspective, many years ago, it was just treatment. We put chlorine in our waters in the UK to get it into distribution. And we also use orthophosphate to stop lead from solvency in customers' pipes. So for many years, we used chemicals. We thought we were fine, and then we started to realise that there was other issues going on, and that you can't just keep increasing the chemical. There's limits to what you can put into distribution, and also by understanding what's going on in the distribution, we can sort of optimize what we're doing, and we can reduce the amount of chemicals we're using, i.e. chlorine. So I've got some images of some pipe work on the right here. So the left pipe here is something that's fairly new, that's been installed, and on the right here you can see that the diameter has been reduced. We've got corrosion, we've got biofilm, and obviously there's an interaction that we're learning between the biofilm, corrosion, and how's that driven, and how can we avoid having to relay pipes because of the diameter and flows reduced. So yeah, so the distribution system, historically, we've got thousands of kilometers of pipe, and we're not fully understanding what's happening in there because it's enclosed. Same with storage tanks. We've got over 800 storage tanks across the region. Again, they're largely enclosed, and we've not got as much access as we would like into them. Also, laboratory techniques and methods were less developed, and also instrumentation was less advanced, looking back. More recently, so Anglian have moved, as well as other UK water companies, to a risk-based method of trying to control biofilm in our networks. So what does that mean? Well, it means that we monitor chlorine levels across the area. We monitor things like temperatures. We feed into that plate counts and other biological monitoring techniques that we've got. We've also been using flow cytometry in the last year. We started full-time monitoring every final water asset and stored water asset from August last year. So we've just got the full year of data to look at seasonality as well. And we also look at things like turbidity to give us an indication of mobilization of biofilm and of metals across our networks. So that's what feeds into our risk-based method. Based on our risk-based method, we then are quite limited really how we can deal with that. But one thing we do currently is flushing. So we go to our highest risk areas. We would then flush that area to try and increase the chlorine, try and decrease the temperature, and to try and mobilize some of the biofilm and keep try to keep it trimmed back, if you like. We've also, in the last 6 months, started looking at concentrated sample surveys. So we have our regulatory points that we go to either daily, weekly, bi-weekly, and monitor. But where we have biofilm issues and regrowth, we've started to properly focus in on those areas now. We're going to customer taps, we're going to other assets as well in that area, and we're taking a lot more samples to try and work out what the drivers are, why these areas are different to other areas, and by understanding that, hopefully it means that we can help to again understand how we can control the biofilm, or how we can move it into an area that we're happy with, that's sustainable and that's giving us positive water quality. The image here is just to give you an idea of some of the pipe works and valves that we're dealing with. We've not got above ground assets. A lot of things are underground in chambers, and that does provide a challenge for us. And we've got a turbidity monitor here. Turbidity is one of the key parameters that we're looking at for water quality change. That is not necessarily biofilm, but it is an easy parameter to monitor. Identifying biofilm. So we've done a lot of work with Sheffield University. I'm not going to get too technical because I know Kat's following me, and that's her bag for today. So I'm going to keep it fairly high level. This is the pipe loop system at Sheffield here, and these straps that you can see on the pipe are where we can take coupons out, and we can look at exactly what biofilm's growing, in the system. This is an environmentally controlled atmosphere that these pipes are in, so we can cool it down. We can try and get it close to what's underground, so we can replicate the distribution system. And then we've got, we use plate counts, we use microscopy and other advanced techniques to look at what's growing on the coupons. And Sheffield have helped us, or helping us, look at communities, how they interact, and so on. We also work with other universities. I've mentioned Cranfield here because we've got a project that we're working on with them. Whereas Sheffield tend to be more distribution looking, Cranfield are more treatment based, and we look at Cranfield, or go to Cranfield to look at treatment. So how can we reduce organics coming into the distribution networks? How can we optimize our treatment so that we can remove the intact cells and total cells, leaving our works and going into distribution that could potentially go on to form biofilms. So how do we categorize them? So again, working with Sheffield academics, they've helped us understand about early colonizers. So what would happen if we put in a new pipe or a new system? Also how the communities develop. So by using genetics and looking at DNA and 16S sequencing, we can start to understand some of the communities, what looks like a stable community, what doesn't, and also the impact of things like chlorine and orthophosphate on the biofilm. So, you know, if we dose additional chlorine, what impacts does that have on that community, and how is it changing? And also, as mentioned in the last talk, we're looking at stable and dynamic systems. Although we don't lose water, we often have really busy times of day where water is being consumed in the mornings and late evenings, and that added flow can strip biofilm and create turbidity events and discolorations. We've got a couple of containers with 2 pipe loops in Anglian now. We've got, you can see there's a black pipe loop on the right and one on the left. They're separate. What we've been doing with these is we can take these containers to each site where we've got a different water matrix and we can run the water through the loop. We can then look at taking coupons that are on the rig here, and we can look at what biofilms being produced by different water treatment works is water matrices. So that's quite exciting. We've had a PhD student, Natalie Lamb, who's actually writing up a thesis on this particular research. So I've not got any data today, and that's due for submission at the end of October. So very hopefully shortly we can start sort of feeding out some of the results from this great piece of work that we've been doing that's on biofilm. Very quickly, we're looking at monitoring. We've got some new things that we're doing with Sheffield and Cranfield. We're looking at flow cytometry, we're looking at FEMs and fluorescence. We've been working with a company called Orb. We've got a fluorescence monitor looking at bulk water and mobilisation of biofilms. And we're also concentrating on organics and AOC from our water treatment works and how that can impact biofilm. I've shown you a quick graph here on the right, is right the way through our treatment works so that we can see emission fluorescence of the bacterial loading as we're going through it. The bottom graph here is just an oddity we had at one of our works where we could see an increase in organics, an increase in cells, and we're keeping an eye out downstream now to see what impact that can have on bulk water and biofilm growth. Final thoughts are, there's a lot to understand. We realise that we've just started the journey. We're not a very long way away, but at least we're there now. We're looking at research and working with academics. Collaborations are essential, working with other companies, other water companies. We're looking at new sampling and monitoring techniques for biofilm, and we fully understand that it's management of and not prevention that's the key to our long systems. So I'd just like to thank Francis Hazard, Dennis Moran, Irene Cara Lorenzo Falzano, and Natalie Lamb for their help that they've given Anglian in the last year and a half.